You've got, in this problem, you've got three springs in parallel with a block, and then you have them in series. And the key is just know what the difference is between the spring constant when they're in series and when they're in parallel. So what I have here is if I have three springs in parallel, I know that the equivalent spring in this example is, well, first of all, let me write in, this is 5 kilograms, and all of the springs are 2 newtons per meter. What? Oh, there's only 2. Oh, okay. Guess what? You might have 3 on the retake. So you only have 2. So you've got 2 springs, and you've got a 5 kilogram mass, and we know that when they're in parallel, the equivalent K, so the K, so I can have 1 K, not 2 Ks, is you just have to add up your 2 spring constants. So in parallel, you just add them up, and there's 2 of them, and they're each 2. So my equivalent K is 4 newtons per meter. So I'm solving for the period, and the formula for the period is T equals 2 pi square root of M over K. Well, the M is given in the problem, and I just showed you what the K is. So plug in there. I know I'm running out of time, so I'm trying to rush through this. But let me show you when you have them in series. So if I have them in series, it's looking like this. And then I'd have the 5 kilograms down here. The key here is, in series, you do it like you would be solving for the equivalent resistance in parallel for a circuit. You're going to do 1 over KEQ is going to equal 1 over K1 plus 1 over K2. So each one of these is 2 newtons per meter. Well, 1/2 plus 1/2 is 1. So even if I flip it over, it's still 1. So my equivalent resistance over here equals 1. So again, the 2 answers are going to be, one of the answers is going to be 5 kilograms over 4, whatever that is for a period, and then I'm going to have 5 over 1, and whatever that is for the period. And that's going to be your 2 answers. They came out to be 7.03 seconds and 14.0 seconds. Now, on the retake, maybe I'll ask you what the omega is, the angular frequency instead of the period. Which, if you can get this, you can get that. The only difference is instead of 2 pi square root of m over k, if you were solving for omega, it's square root of k over m. Okay, so that could be a twist to the problem on the retakes.